Welcome everyone. In this video, we're going to learn how to name inorganic acids. Inorganic meaning acids that start with hydrogen. And if you look here at the definition of what an acid is, one of the definitions most popularly used, they are substances that release hydrogen ions in water solutions. So the acids that we're going to learn how to name will start with hydrogen in front of the formula. Now, acids can be classified either as binary or oxyacids. As you can see on the left, binary acids are acids that only contain two elements, basically hydrogen with a nonmetal, whereas an oxyacid, also known as a ternary for three, are acids that contain oxygen. You will see that it's a hydrogen combined with a polyatomic, and the formula of the polyatomic has an oxygen within it. So that's why they're called oxyacids or ternary acids. Now, the way they are named is differently. If you look at binary acids, which I mentioned consist of just two elements, a hydrogen with a nonmetal, all binary acids will begin with the prefix hydro. Now, if you recall, the nonmetals typically end in IDE. So as an acid, we're going to drop the suffix IDE and we're going to adopt the suffix IC. And after the word is modified, then we'll add the word acid at the end. For example, HCl, which is a binary acid, consists just of two elements. This is one of the most popular acids. It's found in your stomach, and if you use the naming system, we're going to start with the prefix hydro, and then instead of saying chlorine or chloride, we're going to change it so it ends in ic. So it'll be hydro, and then it'll be chloric, and then we're going to add the word acid. So HCl will be called hydrochloric acid. So here is the naming system. So as we mentioned, binary acids, two elements only. They're all going to start with the prefix hydro. The base name of the nonmetal will be adjusted so that it ends in ic. And then you will add the word acid at the end. Here's a few examples. Notice that all of these consist of two elements with the exception of the one on the bottom, which we'll talk about in a minute. So if you crisscross the hydrogen with the nonmetal, you'll get the formula over here. Notice they all start with hydrogen. So the first one is called hydro, and then it will be fluoric acid. HCl, as we saw earlier, is hydrochloric acid. HBr would be hydrobromic acid. HI is hydroiodic acid, and you'll notice the ic ending on all of these. And then the next one, instead of saying hydrosulfic, they add the IC after the word sulfur, so it's just hydro, then sulfuric added at the end there, followed by the word acid. So hydrosulfuric acid. There are a couple of others. We can also add to the list hydrogen with selenium. So this would be hydro, and then selenium would become selenic, followed by the word acid. Okay? We can also do this with tellurium, which is just underneath there. So this would be, well, this is minus 2, I'm sorry. So this would be hydro, telluric acid. Notice these are all binary. We can also do hydrogen with the element phosphorus. When you crisscross this, and by the way, I forgot to put the formulas here. When you crisscross these, you get H2SE. This would be H2TE. This one would actually be H3P. And this one would be called hydro. And then phosphorus would be phosphoric, followed by the word acid. The only exception, notice that this is not a real binary acid. Now, it doesn't contain oxygen, so it's not an oxyacid either. But it does have three elements: hydrogen, carbon and nitrogen. It's hydrogen with cyanide connected. So it's been decided to use the naming system for the binary. In other words, this particular exception does start with hydro, even though it's technically not a binary acid. So it's going to be called hydro, and then instead of cyanide, it'll be cyanic. There's the IC adaptation, followed by the word acid. So it's hydrocyanic acid. Now let's take a look at the ternary acids, which are also known as oxyacids. They consist of 3 elements. It's a hydrogen with a polyatomic. The polyatomic does have the element oxygen, hence the name oxyacids. Now, one major difference, none of these will start with the prefix hydro. So I repeat, the ternary acids or oxyacids will not have that prefix. Now, as you saw, the binary acids all end in ic. These have 2 potential suffixes, either OUS or IC. So let me give you an example. Let's say we had the polyatomic nitrite. So nitrite, which ends in ite, and if we combine it with hydrogen to form HNO2 as an acid, instead of using the ic ending, if it ends in ite, it will adopt the OUS ending. So this, and again, you don't use hydro, so this will simply be called nitrous acid. Now, if the polyatomic ended in 8, like you see here, this is the polyatomic nitrate. This one would be the normal ending. When I say that, I mean it'll end in ic. So this would be HNO3. So nitrite will become nitrous, whereas nitrate will adopt the ic ending. And this one would be called nitric, followed by the word acid. They're all going to end in the word acid at the end. Now notice the prefix hydro is not being used. So here's a summary of this. When you have an oxyacid, it might end in ite or it might end in 8. It depends on the polyatomic. So if the polyatomic ends in ite, like in nitrite, it will adopt the OUS ending, like nitrous, followed by the word acid. If the polyatomic ends in 8, it will adopt the ic ending, followed by the word acid, like in nitrate, it would become nitric acid. Here's a few examples, okay? Notice the first one is nitrite and the second is nitrate. So we covered this one already. This is nitrous versus nitric acid. But then look at the next 2. This is sulfite and sulfate. So the sulfite will become sulfurous acid. And notice we're crisscrossing it here. You have everything set up on the left here. So it's sulfurous acid, and then the sulfate will become sulfuric acid. Take a look at the next 2. Phosphite and phosphate. So phosphite would become phosphorus acid, and phosphate will become phosphoric acid. And then we have the one that we have the 4. Remember, this is hypochlorous. Hypochlorous. This is just chlorous, chloric, perchloric. So, the polyatomics, actually, I named them as acids already. The ClO negative, okay, if you remember, it's called hypochlorite. So when it becomes an acid, it will be hypochlorous acid. The second one over here, that's chlorite. So it becomes chlorous acid. The third one is chlorate. Again, the 8 ending will adopt the ic. So this will be chloric acid. And then perchlorate will adopt and become perchloric acid. So there you have the 4 that we had mentioned with the polyatomics. So it's very important that you remember that if the polyatomic ends in ite, we'll change it and it will adopt the OUS ending. and if it ends in ate, it will adopt the ic or IC ending. Now remember that all ternary or oxyacids, they do not begin with hydro. The prefix hydro are only for the binary acids. Now here's a list of some common ones. Now we've already addressed all of these, but look at the last two. That's acetate, if you notice, and acetate ends in ate, so it's going to adopt the ic ending. So the acid, once you combine it with hydrogen, acetate will become acetic acid. And then you have, and you see them over here, the polyatomics, you have carbonate. So when carbonate combines with hydrogen to form an acid, carbonate will become carbonic acid. Again, they end in ate, so they adopt the IC ending. Okay? Here's a couple of others that you might encounter. We can have hydrogen with, if you recall, this is the polyatomic chromate. And when you crisscross this, you're going to get H2CrO4, and chromate will become chromic acid. Okay? And then we have another one, a counterpart of this. We got H with Cr2O7. If you recall, we'll crisscross it now, but that is dichromate. So when you crisscross it with hydrogen so it becomes an acid, it'll be dichromic acid. So chromate becomes dichromic acid. And then I'll give you one more that you might encounter. This is the polyatomic ion permanganate. So when you crisscross it, you're going to get this. And permanganate will become permanganic acid. So these are just a couple of other ones that still follow the same rule. They all end in ate as far as their polyatomic is concerned. And notice none of these start with hydro. So it's very important. The first thing you do is when you're naming an acid, identify if it's binary or ternary. If it's binary, they start with hydro. They all end in ic, followed by the word acid. If they're ternary or oxyacids, none of them will start with hydro. And then look at the ending. If it ends in ite, you adopt the OUS ending. If it ends in ate, you adopt the IC ending. And whether you're a binary or a ternary acid, all of them will end with the word acid. Okay?